All right, today in Algebra 2, we are doing 3.2, solving systems algebraically. Okay, I'm breaking this section down into 3 days. Today we're going to focus on substitution only, okay, because there's a lot to understand with solving systems. It's not like it's probably the first time you've seen it. I don't imagine that you saw it in Algebra 1. So this is not so much review as new information. So our objective today is to solve systems of linear equations by substitution. Last class we did graphing, okay? But there's a little note here. Solving systems of linear equations by graphing is not always an option. Okay, graphing is not always an option. So you can solve algebraically using one of two methods. Today we're going to focus on substitution. Okay, now solving by substitution. The way that we can do this is we're going to reduce the system to a single equation by solving either equation. Then we're going to substitute, that's where it gets its name, that expression. We're going to substitute an expression, not a number, not one single value. We're going to substitute the expression into the other equation. Okay, once we have the new equation, or once the new equation is solved, we're going to substitute again that number, this time we're going to substitute a number, into the original equation and solve for the other variable. And that probably sounds wicked crazy, but I'm going to make it make sense. We use substitution when you have a variable with a coefficient of 1. So if we look at this example, 3x plus y equals 7. This y has a coefficient of 1. It's a perfect time to use substitution. If we look at this equation, x minus 2y equals 9. The x has a coefficient of 1. It's a perfect time to use substitution. Okay, you can use it other times, but that's the ideal situation when to use it. Okay, so I'm gonna erase a little bit and move up so we have plenty of workspace here. Okay, so I'm going to try to leave that solving by substitution. Okay, so solve the system. We have 3x plus y equals negative 20 and y equals x minus 8. Okay, so we said the first thing we wanted to do was to reduce the system to a single equation by solving either equation. So we're going to solve for a variable. You just have to pick one. The nice thing is this one's already solved, right? It says y equals x minus 8. In this case, we don't have to do any work. Okay, we're ready for this next part, because then it says substitute that expression in the other equation. So we have y equals x minus 8, and we have a y right here. So we're going to substitute this expression, x minus 8, into the y. So we're going to take 3x plus y. We're going to use that quantity x minus 8 equals negative 20. So the part that we substituted in was right there, and it came from right here, x minus 8. But now we can solve this for the variable x because I have two x's instead of having an x and a y. Okay, that's the goal. All right, so there's nothing we can do inside the parentheses. There's no distributing to be done, so we're left with 3x plus x minus 8 equals negative 20. We can combine like terms. 3x plus x is 4x minus 8 equals negative 20. We're going to add 8. So we have 4x equals negative 12. Divide by 4. And we have x equals, good, negative 3. Okay, the next thing. Once the new equation is solved, substitute the number, because now I have x equals a number, negative 3, into an original equation and solve. Okay, so it doesn't really matter which one we choose. You can choose either one. Okay, and we can do it twice. So I'm going to take this. Let's do the 3x plus y equals negative 20. Okay, I'll do that one first. I'm going to plug this x equals negative 3 in for there. So I'm going to have 3 times negative 3 plus y equals negative 20. So negative 9 plus y equals negative 20. I'm going to add 9 to both sides and get y is equal to negative 11. Again, I can plug it into either equation. So if I had chosen y equals x plus, or x minus, pardon me, 8, I'm going to plug my negative 3 in there. Y equals negative 3 minus 8. Y equals negative 11. It does not matter which equation you choose to plug it back into. And so then we have a solution. Our solution is a coordinate. It's negative 3, negative 11. Right? That is our solution. So classify this type of system. Is it independent consistent, dependent consistent, or inconsistent? Okay, if it has one solution, right, then we know it's IC. It's independent consistent. So substitution. We're doing substitution, substitution, more substitution. That's what it's all about. All right, I'm going to clear this and move on to example 2. All right, in example 2, we're going to solve this system. Okay, this one's not as nice. We're going to have to do some work to solve. Again, we're looking for that coefficient, that variable that has a coefficient of 1. Which equation has a variable with a coefficient of 1? Yeah, that top one, right? This 2x minus y equals 8. So that's the one I want to solve for, and I want to solve for y. So 2x minus y equals 8. So I'm going to subtract 2x, which leaves me with negative y equals negative 2x plus 8. I'm going to divide by negative 1 because we can't have a negative y. Y equals negative 2 divided by negative 1 is a positive 2. X, 8 divided by negative 1 is negative 8. Okay, so there's my equation that I solved for a variable. Now, I'm going to take that expression, right? Y equals this amount, y equals 2x minus 8, and I'm going to plug that into my other equation for y. Okay, so I'm going to take 4x plus 3y equals 2. Okay, I'm taking my second equation, and I'm going to plug in a value, an expression for y. So I'm going to keep 4x plus 3 times my y right here. So 3 times 2x minus 8, that's my y, equals 2. Okay, that's where I substituted. So I do have some distributing to do. So 4x plus 3 times 2x is good, 6x. 3 times negative 8 is excellent, negative 24 equals 2. I can combine like terms. 4x plus 6x is 10x minus 24 equals 2. Okay, I can add 24 to both sides of the equal sign. 10x equals 26. Divide by 10. X equals 2.6. I feel like I need to check that, like I made a mistake. Nope, that's okay, 2.6. You know what though? I would probably rather have that as a fraction. It's going to make my life easier. So 2.6, or I could reduce this to be 13/5. That would probably make my life easier. All right, but now I have a value for x, or a number. Now that I have a number for x, I can plug that back in to one of the originals. So now my x is going into an original. Does not matter which original you choose. Okay. So I'm going to take the one with the smaller numbers here. So 2, right, 2x So I'm going to use this 2x minus y equals 8. Okay, and I'm going to plug in my x value. So I'm going to have 2 times x. Well, wait a minute. X is equal, I tried to change my color, it didn't go. X is equal to 13/5. Okay. Then minus y equals 8. So that's where I plugged in the 13/5. So 2 times 13 is 26/5 minus y equals 8. So I'm going to subtract 26/5 from both sides. Negative y equals, let's see, if we made this would be 40/5, right? So 40 minus 26 would be 14/5. Yeah, 14/5. Okay, I have a negative y, can't have, so I'm going to divide by -1. Y equals negative 14/5. Guess I should have circled that because that's not my final answer. So I have a solution. My solution is the ordered pair 13/5, comma, negative 14/5. That is my solution. Okay, since I have 1 point as my solution, what type of system do I have? Excellent. It is independent consistent. Again. Woo woo. Doing fantastic. All right, I'm going to flip this over. I don't even know if I have it back. I do not. I didn't think so. Just those 2 problems today. So I will see you guys tomorrow, and you should be excited that we have a worksheet to do on just substitution. All right, have a great day.